Alright, using the ratio test, the series converges if the limit as n approaches infinity of the n plus 1th term divided by the nth term is less than 1, which simplifies to this, which simplifies to this open interval. Part B. Trying to find this limit is impossible at first because we have the indeterminate form of 0 over 0. So we'll use L'Hopital's rule. The derivative of the top is f prime of x minus 0, and the derivative of the bottom is 1. So it's equal to the limit as x approaches 0 of f prime. So what is f prime? F prime equals, we could find the rule for it with summation notation, but let's just take a look at a term-by-term basis. The first derivative of the fifth is 0, the first derivative of that term, derivative of the third term, fourth term. And notice every term has an x in it, except for this term. So, as x approaches 0, f prime of x approaches all these terms that with x's in them are zeros, so just 2/25. For part C, we need the antiderivative of f, at least the first three non-zero terms. So let's go ahead and do it again on a term-by-term basis. The antiderivative of a fifth is a fifth x. The antiderivative of this x term is going to be an x squared term. The antiderivative of the third term, and we can keep going that way, but we only need the first three non-zero terms. So we've got non-zero terms, and using the fundamental theorem of calculus, we're evaluating this from 0 to 1. So when we put a 1 in there, we get these three terms, minus, when we put a 0 in there, we get 0. So these are the first three non-zero terms they asked for, and a general form for the nth term would be 1 over 5 to the n. Alright, part D. The sum of the series is easy. That's just a geometric series where the first term is a fifth, and r, the common ratio, is a fifth. So we have a fifth over 4/5, which is 1/4. There's number 57.